Hey friends, it's good to be back with you. Today I'd like to go over some final thoughts about linear algebra. That seems kind of ominous, doesn't it? But you know what I mean. What I'd like to do is go over a problem that's a little more involved than the ones we've seen before and show you a couple of things. The first is that we already have enough tools to be able to solve this. The second is that since we're writing these matrices out just in letters here, this is independent of how big those matrices are. This problem isn't any harder for 1,000,000 by 1,000,000 matrices than it is for 2 by 2. It's the same. That's powerful. And because of that, this isn't that much harder than the kind of algebra you learned in 8th grade, probably, junior high school. And the last thing I'd like to do is go to my computer and we'll solve this using MATLAB, using those values for these matrices. So just A, B, and C are matrices, D is a vector. Well, let's try it. Let's see what happens. Okay, the big thing to remember here is that matrix multiplication is not commutative. In simpler terms, that means order matters. That is, A times B is not going to equal B times A, well, unless A and B are inverses of each other. But in general, A times B is not equal to B times A, so order matters. So how am I going to solve for X, which is what I'm trying to solve for here? I got to get rid of A and B on this side. Well, if these were just numbers you just divide through, well, you can't do that with matrices, but you can come close. Let's try this. There's a couple of ways to handle this. Let's pre-multiply by the inverse of A. Now I can gather terms here just like you can with numbers. Yeah, here we go. Okay, so all I've done is pulled the D out. That's fine, and D is at the end, so I've had to keep the position there. And I'm going to pre-multiply here by A inverse. So far, so good. Well, what's A inverse A? Well, that's the identity matrix. And I'll just recopy this here, I guess, for reasons of good form. Okay, so I times B equals B, B times I equals I. This is one of the few times where order doesn't matter, because this is 1. This is identity. If you multiply I times B, that's also B times I, and it's just B. So that just goes away. I don't need it there anymore because it's a 1. So last thing I got to do is somehow make B go away. Well, let's just do the same thing. Multiply through B inverse B. Okay, pretty easy, huh? B inverse B is just I is 1. Don't need it. There we go. There's how to solve this. Now this doesn't look that much different than the problems we've solved before, and we're using the same tools. Just remember that here, if I pre-multiplied on this side, I have to on that side I have to pre-multiply on this side. Okay, so order matters. That has to be B inverse A inverse. I can't reverse those. So as long as I preserve my order, we're good to go. Okay, before we get too much farther, some of you have certainly noticed that there's another way to do this. So before we stop, I'm going to erase this over here, and let's take a different approach to solving this same problem, okay? Okay, if you look at this, A times B is a matrix, and C times D, that's going to be a vector, and that's going to be a vector. Well, why don't we just call this a matrix and all that mess over there a vector? Well, I'm starting to run out of letters here. Let's call this one maybe A, B, C, D, E. How about F? And we'll call this maybe G. I don't know. We're running out of letters here, but those will do for right now. So the capital will indicate, as it has over here, capital is going to be the matrix and little is going to be the vector. So F is just A times B, matrix multiplication. We know how to do that. And G is two matrices multiplied by vectors and then one subtracted from the other. So C times D minus A transpose D. So matrix vector, and that's going to be a vector. Well, if you write it out that way, F X equals G, and X equals F inverse G. That's another way to do this, and it works just as well. If we've done our job correctly, this and this are going to be mathematically identical. So let's go to my computer and run this all in MATLAB.